Hello everyone, today is Unit 6 practice test video. Unit 6 practice test video. So let's get started. Okay, in front of you, you should have your practice test. Follow along carefully with me. Take good notes on the practice test. Fill everything in as you go. Let's start with numbers 1 and 2. Find the square roots. Okay, find the square roots. Number 1, we're looking for the negative square root of 1600. So basically, we're looking for the two numbers, when you multiply them together, gets you 1600. Okay, so in this case, it is 40 times 40 is equal to 1600. So the negative square root of 1600 would be negative 40. So for number 1, finding the square roots, 40 times 40 is 1600. We're taking the negative of that, negative 40. Number 2, square root of 25 over 49. So in this case, we have the square root of 25 and the square root of 49. 25 is a perfect square, which is 5 times 5. 49 is a perfect square, 7 times 7. So this is equal to 5/7 perfect square times 5/7. 5/7 times 5/7 is equal to 25/49. So if we're looking for the square root of 25/49, your answer will be 5/7. 5/7. And you could circle your answer there. Also put your answer in where number 2 is, 5/7. Okay, so just like the square roots, you're going to have a few problems on cube roots. So we're looking for the number that when you multiply it 3 times.
Emma Rodriguez, to the front for your ride. Emma Rodriguez, please come to the front for your ride. Thank you.
So when you multiply that number times itself and then times itself again, you would get negative 27. Negative 27. And that number, this is also a perfect cube, which would be negative 3. Negative 3 times negative 3 is a positive 9. Positive 9 times a negative 3 is negative 27. So the cube root of negative 27 would be negative 3. And that'd be one of those perfect cubes we've talked about in class. Number 4, the cube root of 8 over 125. The cube root of 8 over 125. Again, we have a couple perfect cubes here. 8 1/25. The cube root of 8 is 2, and the cube root of 125 is 5. So we have ourselves 2/5 times 2/5 times 2/5 is equal to 8 over 125. So the cube root of 8 over 125 would be 2/5. And that would be the first section, finding the square root for numbers 1 and 2, and finding the cube root for number 3 and 4. Okay, moving along to numbers 5 and 6, 7 and 8, evaluate the expression. Okay, so look for perfect cubes, look to simplify if you can underneath the radical, and simplify all your perfect cubes, perfect squares as you go forward here. There's only 4 of these. Number 5, 12 plus 8 times the square root of 16. Okay, my I goes to the square root of the 16 first. That's a perfect square. So that's a perfect square. The square root of 16 is 4. So write that down. So when you're evaluating, you're doing your PEMDAS 8 times 4, which is 32. So you're adding to 12 plus the 32, and you end up with 54. So 12 plus the 32 is the 44. 8 times 4 is 32, plus 12 is 44 for number 5. Number 6, 1/2 plus the square root of 72 halves. So I see I can simplify underneath the radical. 72 divided by 2 is 36. And we're looking for the square root of 36. My eye goes to that 36. It's a square root. That's a perfect square. Square root of 36 is 6. So 1/2 plus 6 is 6 1/2 for number 6. Number 7, we have the cube. So those two are square roots. The second two are going to be cube roots. Let's take a look at 7 and 8. The cube root of negative 125, and then we are cubing it plus 75. The cube root of negative 125, and then we're cubing it, then add 75. So you may notice that when we are taking the cube root of something and then we're cubing it, this is like undoing the cube root. When we cube something that of a cube root, we're undoing it. So what this is this kind of cancels each other out. We have a negative 125. So again, we're undoing the cubing. We're cubing the negative 125. So we undo the cube root of it. So negative 125 plus 75 is negative 50. That'd be your answer for number 7. Number 8, 15 plus 3 times the cube root of 125. Okay, so again, we have a perfect cube here in 125. What number, when you multiply it 3 times in a row, it gets you 125, and that number is 5. So again, you're looking for that number multiplied by itself, then by itself again, and you would end up with that 5 times 5 is 25. 25 times 5 is 125. 15 plus 3 times 5 is 15. And your answer for number 8 is 30. And that concludes the first 8 of the practice test, page 1.
Leanne Bittner, please call 4361. Leanne, call 4361.
Moving on to number 9. A cube-shaped package has a volume of 5,832 cubic inches. What is the edge length of the package? Okay, so we're looking for the answer case here that the keyword is cube. Okay, so we have cube shaped. So if you think of a package, it's shaped like a cube. Okay, so all the sides are the same size. So it's shaped like a cube. like so. So let's call that X, and it says the volume of this package, then the volume of a cube is X to the third. That's the volume of the cube. X times X times the X. Now that's going to equal 5,832. Now, when you're looking at a cube of a number equal to a number, to undo the cubing of a number, you take the cube root of it. So we're going to take the cube root of the left side and the cube root of the right side. And when you take the cube root of a number that's already cubed, that ends up being just the X. And if you take the cube root of 5,832, that value is 18. And the use of your calculator could work with that one, a number 18. All right, let's move along to the next section, which is finding the missing length of the triangle. So I should put down 18 inches for number 9, 18 inches. So numbers 10 and 11 is the Pythagorean theorem. So if you look at 10 and 11, you're going to be looking at a squared plus b squared is equal to c squared. Okay, so for both of them, we're going to be looking at a squared plus b squared is equal to c squared. Now keep in mind here, folks, that we are already given that these are right triangles. So we're not proving that it's a right triangle, we're just finding the missing side, okay? So in this case, it's labeled as C, and it happens to be the hypotenuse, which corresponds to the c squared. The other two for number 10 would be legs. 12 squared plus 35 squared will equal the hypotenuse squared. Okay, so 12 squared is 144. And if you add 35 squared is 1225, 1,225. And that will equal to the hypotenuse c squared. Now, if I add 1225 plus 144, that brings me to 1,369 is equal to the hypotenuse squared, c squared. Okay, so at this point, we're still trying to solve for c. And if we have a c that is squared, we can take the square root of both sides to undo that squaring, square root of 1369, and that will give you the c. So the square root of 1369 is 37. So 37 inches would be your answer for number 10. The use of the Pythagorean theorem. Okay, 37 inches. Number 11, finding the missing length of the triangle. So in this case, the hypotenuse is across from the right angle, and that's the C, 0.5. So once you have that out of the way, that's going to be squared. We can fill in the other two with B, corresponds to the B, why not? And the A corresponds to 0.3, and it's all in centimeters. So 0.3 times 0.3 is 0.09 plus B squared is equal to 0.5 times 0.5, which is 0.25. Now we can solve 0.25 we are going to subtract 0.09 from both sides, 9 100ths from the left, and 9 100ths from the right. And that brings us to b squared is equal to 0.25 times 0.25 minus 0.09 is 0.16. Okay, so you're probably thinking, well, now what do I do? I've got a b squared is equal to 0.16. And we are at this point going to take the square root of both sides. So when I take the square root of the left and I take the square root of the right, I end up with b is equal to 0.4. 0.4 for the answer. So 0.16 square root is 0.4. So that for number 11 would be 0.4 centimeters. And that would be finding the missing length of a triangle using the Pythagorean theorem. You already know that they're right angles. Just make sure that you place mark the correct length of the side with the A, B, and C for number 10 and 11. Moving on to numbers 12, 13, and 14. We are classifying real numbers, rational or irrational. So if you look at number 12, 16 pi, pi is irrational, and you multiply anything by an irrational number, you get an irrational product. Irrational. Number 13, you have the negative of a square root of 49. Now this square root of 49 is a perfect square. So that's up being a -7, and -7 is rational. It's an integer. Number 14, 0.36 with 36 repeating, 36, 36, 36, 36. And with this one in mind, it is repeating the same thing. So repeating decimals are rational if they are repeating the same thing. 36, 36, 36. So number 14 will be rational. Okay, and that's that section, classifying real numbers, rational or irrational. Okay, moving down to the last section on page 2, numbers 15, 16, and 17, which are estimating the square root to the nearest integer. Okay, so we had quite a few of these in our when we had this section. And we primarily used our number line with our perfect squares. These numbers are a little bit bigger, so I'm going to start like at 6, for instance. 6, 7, 8, 9, and 10. Okay. So if you're looking at perfect squares, it equals 10 would be 100. The square root of 100 is 10. The square root of 81 is 9. The square root of 8 is 60. I should say the square root of 64 is 8. The square root of 49 is 7. And the square root of 36 is 6. Okay, that'll get us pretty close. So we're going to use this number line here with the perfect squares. Now, if you had smaller numbers, you have to go further this way or that way. But the first one would be square root of 58, okay? So we're looking to find the nearest integer. So the square root of 58 lands right about in here, okay? So the square root of 58 is 4, 5, 6 spots away from 64 and 8, 9 spots away from 49. So the square root of 58 lies right about in here. And if we're looking to estimate that to the nearest integer, the nearest integer would fall closer to 8 than to 7. So your answer for number 15 would be 8. The square root of 58 is closer to the square root of 64, which would be 8, than it is to the square root of 49, which would be 7. Okay, I'm just going to switch different colors for the next one just to get a little bit of variety here. Square root of 83. As you can go along this number line here, square root 83 is right past 81. Square root 83 is right about just past 81 would be the square root of 83. It is only 2 numbers past 81, and it's 17 numbers from 10. So if you're asked to estimate the square root to the nearest integer for number 16, the square root of 83 is closer to 9, the square root of 81, than it is the square root of 100, which would be 10. So the integer that's closest to square root of 83 would be 9. Number 17, the square root of 90. Now just past 83 is the square root of 90. So I'm gonna write that one down. The square root of 90 is 10 units from 100 and 9 units from square root of 81. So again, this one is closer to the square root of 81, which is 9. And that would be that section. So use your number line, use your perfect square number line to help you with those types of questions on the final test, 15, 16, and 17. Okay, moving to the last page of the practice test for Unit 6. Determining which number is greater. Okay, so in this case, we are trying to determine which number is greater, okay? So some of these will be quite obvious. Some of them you might have to work a little bit for. The square root of 11 is, if you had to guess this or find a guesstimate, the square root of 11 is between the square root of 16, which would be 4, and the square root of 9, which would be 3, okay? The square root of 9 is 3. The square root of 16 is 4. The square root of 11 is going to be just past 9, 10, 11, would be right about in here, square root of 11. It's only a couple numbers away from 9. 3 and 3/5 is past, good past a half between 9 and 16. So if you look at this on which one is greater, it's fairly simple to see that 3 and 3/5 is going to be located 2, 3, 4, 5, 1, 2, 3, right about in here would be 3 and 3/5. And 3 and 3/5 would then be the greater number. Square root of 11 is going to be right closer to 9. It's not halfway because 16 and 9, 6, 7, it'd be 3.5 points, would be like 12 and a half. So the greater number in this case is 3 and 3/5 for number 18. 1.44 square, okay, so that's number 18. Moving on to our last question on this section, which is which number is greater? The square root of 1.44 is 1.2, I believe. So the square root of 1.44 is 1.2, because 12 times 12 is 144, and we have the decimal places to move the decimal over. So this is 1.2, this is 1.1 with the 8, and the 8 is the only thing that's repeating. So they're asking which number is greater, so the number that's 1.2 will be greater than 1.188 repeating. And that would be number 19. Number 19. Which number is greater? So look at your perfect squares and your number line to help you with those types of questions on the final test. All right, now we're going to move to 20 and 21, finding the distance between 2 points. So this is the use of our distance formula. And I'll just switch colors here, change it up a little bit. So the distance formula will be the same for both questions. And I'm going to run out a little bit out of room here. So I'm just going to try to work these x of 2 minus x of 1. And we're going to square that. Then we're going to add it to the square root of y. I should say y of 2 minus y of 1. And that's also going to be squared. So we're going to add those two together and we get the square root. So we'll use the same distance formula for the 21. So let's write that down. Square root of x of 2 minus the x of 1. And that value is squared. Plus y of 2 minus y of 1, and that value is squared. Okay, so we're using the distance formula for both of them. Now, again, I kind of gave you some hints on how to approach this. You're going to want to declare those, the x of 1 and y of 1, and the x of 2 and y of 2. So it will just help you when working with the formula. Okay, so let's work with number 20 now.
Could the custodian please check the men's restroom in the B wing on the first floor? There seems to be some leaking in the men's room in the B wing on the first floor. Thank you.
Okay, so x of 2, which is 6, okay, 6 minus x of 1, which is negative 2. And we're going to go ahead and square that. Plus y of 2, which is 9, minus y of 1, which is 3. We're going to go ahead and square that. Okay, so remember, when we're subtracting a negative, it's the same as adding a positive. So 6 minus a negative 2 is 8 squared. Plus 9 minus 3 is 6 squared. And simplify next step, 8 squared is 64, plus 6 squared is 36. Okay, 6 squared happens to be 36. And you can see where this is going. 64 and 36 is the square root of 100. And that is equal to 10. So the distance between negative 2 comma 3 and 6 comma 9 is 10 units for number 20. Number 21, 0, negative 5, and 4 comma 1. Okay, again, I'm just going to put x1, y1, x2, y2. And this will help me when I start working with my relationship here. Okay, so x of 2 is 4. Subtract x of 1, which is 0. And then I'm going to go ahead and square that. y2, which is 1, minus y1, which is -5. And then I'm going to go ahead and square that. So 4 minus 0 is 16. Is 4, I should say. And then if we're going to square that, is 16. A little ahead of myself there. 1 minus a -5 is 1 plus 5, which is 6. 6 squared is 36. 36. So your answer here would be 36/46 square root of 52 for your answer for number 21. Square root of 52 for the answer for 21. So again, your x1 is 0, y1 is -5, x2 is 4, y2 is 1. So your x of 2 minus x of 1 is 4 minus 0, squared is 16. y2 minus y1 is 1 minus a -5 is y plus 5, which would be 6, squared is 36. 36 plus 16 is 52. Square root of 52 is the distance between 0, -5 and 4, 1, the distance formula. Number 22 and 23 today are the verifying whether or not the given side, with the given sides, whether or not we have a right triangle. So this again is the kind of the backwards of the Pythagorean theorem. We're trying to determine whether our Pythagorean theorem works here. A squared plus b squared is equal to c squared. Okay, so we're trying to determine if that works. If it is, we're going to consider it yes, it's a right triangle. If it doesn't work, we're going to say no, it's not a right triangle. So let's go ahead with this first one. The longest side is the C. So in this case is 53, 53 squared. The other two sides would be the legs of the triangle, 46 squared plus the 28 squared. Okay, so this is some calculator work, and you could use your calculator for these types. And if you look at this case, you have 46 times 46, and that's equal to 2,116. And then we're going to add it to 28 squared, 28 times 28, that's equal to 784. So 784 plus 2116 is 2,900. And now if 2,900 is equal to 53 squared, we have ourselves a right triangle. So 53 squared is equal to 2,809. Okay, so if that's equal to 2,809, we then can conclude that 2,900 does not equal 2,809. And because it does not equal it, we can say no, it is not a right triangle for 22. So your answer for 22, whether or not it's a right triangle, is no. 23, same thing. I'm going to switch colors here back to my other colors here. Start with our relationship. A squared plus b squared is equal to c squared. And we're checking it out. We're checking to see if it is. If it is true, then we conclude yes, it is a right triangle. The longest side in this case is 3.7. and that value is squared. The other two could be our legs, 3.5 squared plus 1.2 squared. And we're checking to see if this is true. Okay. All right, so I'm going to use my calculator for this, 3.7 times 3.7, and I have 13.69. And 3.5 times 3.5 is equal to 12.25. One 1.2 times 1.2 is 1.44. If you add that to the 12.25, you get 13.69 on the left. And it is equal to 13.69 on the right. And so it is equal to each other. This is, yes, it is a right triangle. So number 22 is no, it didn't work out. 23 did work out. So this definitely is a right triangle, number 23. So don't take the pictures. The pictures are meant to deceive you. You got to do the work to determine whether or not that works out. Okay, that brings us to our last question on the third page is the extra credit. It says find the missing length of the figure. So you have yourself a figure here. You got basically a square. The reason why I know it's a square is because we've got these little markers here. Basically, everything's one mark, so we know that this side is 12. And if this side is 12, this height of this right triangle will be 12. Okay, so this side is 12. The height of this 12. So with that in mind, we know the hypotenuse of this right triangle. Now we're told that it's right. So this is right triangle here. So across from it is the hypotenuse, which would be the 20. So the Pythagorean theorem is what this question is all about. Identifying first that we have a height of the triangle at 12. A squared plus B squared is equal to C squared. Okay. And as you can see here, the height is 12. The hypotenuse is 20. So that C is 20. So we're going to square that. And that's going to equal one of our legs is x squared. And the other leg is 12 squared. Okay. So solve for x. We first take 12 and square it, 144. Then we're going to take 20 squared. 20 times 20 is 400. Now we're going to solve for x by subtracting 144 from both sides. And when we subtract from both sides 400 minus 144, we get x squared is equal to 400 minus 144, which is 256. 256. Okay, so the square root of 256. Okay, so if we take the square root of 256, you're going to have the square root of 256. 256 square root is 16. So to undo this squaring, you take the square root of the right and the square root of the left, and you end up with the answer of x is equal to 16. X equals 16 for that value. And that concludes the practice test today on Unit 6. Hope you found this beneficial. Take a good look at all of the pieces of the puzzle here. I hope you found it beneficial. Ask questions if you have any final questions before we take our unit test coming up shortly. Thanks very much for listening and have a great day.